In the grand, cathedral-like silence of the cosmos, there exists a quiet so profound it transcends the mere absence of sound. It is a fundamental state of being, a silence woven into the very fabric of space-time. Here, in the vast, unlit corridors between the stars, the temperature hovers just fractions of a degree above absolute zero, that theoretical point of perfect stillness where all atomic motion nearly ceases. This is a cold that does not just chill the bone, but stills the universe itself. Sound, as we understand it, a vibration traveling through a medium, has no purchase here. There is no air to carry a whisper, no ocean to transmit a call. There is only the void, an emptiness so complete that it has endured for billions of years, witnessing the birth and death of suns in a state of majestic indifference. Time itself seems to stretch and thin out in these lonely expanses, with journeys measured not in days or years, but in epochs. A single photon of light, the fastest thing in existence, can travel for 1,000,000 years without encountering anything at all, a lonely messenger crossing an eternal night. We, on our small, noisy world, can scarcely comprehend such a reality. Our existence is defined by vibration, by the ceaseless hum of life, the crash of waves, the rustle of leaves, the symphony of language and music. We fill our lives with sound to stave off the void, to communicate, to connect, to assure ourselves that we are not alone. Our entire biology is tuned to its frequencies. Our civilizations are built upon its patterns. To us, silence is a pause, a brief interlude in the grand composition of existence. But out there, in the deep, silence is the composition itself. It is the rule, not the exception. And yet, humanity has learned to listen to this silence. Our ears for this domain are not made of flesh and bone, but of polished mirrors and sensitive electronics. Our hearing extends beyond the audible, into the vast, invisible spectrum of light. We listen with telescopes, vast instruments of synthetic perception that gather the ancient whispers of the universe, the faint, weary light from distant galaxies, the cryptic radio pulses from spinning neutron stars, the gentle infrared glow of stellar nurseries where new suns are being born. This is how we conduct our dialogue with the cosmos. Not by speaking, but by observing. Not by shouting into the void, but by patiently, meticulously, listening to the stories that light has carried across eons to tell us. We have learned the rhythms of this silent music, the predictable orbits of planets, the steady burn of stars, the slow, graceful waltz of galaxies. We have come to recognize the standard chords and melodies of the physical laws that govern this majestic clockwork. But sometimes, in the midst of that near-perfect quiet, something happens that does not fit the composition. Something breaks the rhythm. It is a note played out of key, a whisper in a library where all the books were thought to be written. It is a silent scream. A silent scream is not a sound. It is an event, an observation so anomalous, so contrary to the established order of things that it shatters our complacent understanding. It is the universe revealing a secret it has held in abeyance. It is the discovery of a phenomenon that should not exist, according to the very laws we have worked so painstakingly to decipher. A supernova is a shout, a violent, explosive announcement of a star's death that can briefly outshine an entire galaxy. A black hole merger is a gravitational drumbeat, a tremor in space-time itself. But a silent scream is more subtle, more unsettling. It is the discovery of a quiet process occurring where only static equilibrium should reign. It is the flicker of a candle in a chamber sealed from all wind. It is the sight of footprints appearing on a pristine, untouched canvas of snow. It is an act of impossible vitality in a domain defined by quiescence. This is what astronomers seek in the endless streams of data, the ghost in the machine of the cosmos. And when they find it, it marks the true frontier of knowledge. It is a moment that forces us to question everything we thought we knew, to redraw our maps of reality. It is a humbling and exhilarating reminder that for all our progress, we are still just children on the shore of a cosmic ocean, and its depths are far stranger and more wonderful than we can possibly imagine. This particular scream, the one that concerns us today, emanates not from a dying star or the violent heart of a galaxy. It does not come from some grand cataclysmic event. It originates from something small, dark, and cold. Something lonely. A solitary traveler, a pilgrim on a journey of unimaginable length, carrying with it a message from a place beyond our own solar family. It is a whisper that speaks of impossible warmth in the heart of the deepest cold, a paradox that challenges the very nature of its kind, and in doing so, asks us a profound question about the universe and our place within it. Now, let us turn our gaze from the abstract to the specific. Let us focus our collective attention on that single, unassuming point of light, drifting patiently against the tapestry of the fixed stars. Its official designation is 3I divided by Atlas, a name that is both clinical and, in its own way, poetic. The 3I identifies it as only the third interstellar object ever confirmed to have entered our solar system, a visitor from the vast, uncharted territory between the suns. The name Atlas comes from the terrestrial survey that first noticed its faint signature, the Asteroid Terrestrial Impact Last Alert System, an instrument designed to be our planetary sentry to watch for dangers approaching from the dark. Yet, this object was not a danger. It was a mystery. It is not a member of our familiar celestial family. The planets, asteroids, and comets of our solar system are all bound by the invisible tether of the sun's gravity. They are natives, born from the same swirling protoplanetary disk of gas and dust some 4.5 billion years ago. They follow predictable, elliptical paths, their journeys endlessly repeating in a cosmic dance choreographed by gravity. They are ours. But 3I divided by Atlas is different. Its trajectory is not a closed loop but an open-ended hyperbola, a path that speaks of immense initial velocity, a speed that could not have been imparted by our sun alone. It is a cosmic slingshot, shot from the gravitational bow of another star, long ago and far away. It has traveled for an unknowable duration, perhaps millions of years, crossing the desolate void between stellar systems. It is an emigrant, a wanderer, a true alien in the most literal sense of the word, originating from another world, another Genesis. And as it navigates the outer reaches of our solar system, it is doing something that, by all rights, should be impossible. To understand this paradox, you must first picture its environment. It moves through a realm of profound cold, far beyond the orbit of Mars, beyond the asteroid belt, journeying through the frigid domain of the gas giants. At this immense distance, the sun, our brilliant, life-giving star, is but a shadow of its familiar self. It would appear not as a disk, but as an intensely bright star, its warmth and energy diluted by billions of kilometers of empty space. The sunlight reaching 3I divided by Atlas is a feeble caress, hundreds of times weaker than the light that bathes our own planet. In such conditions, a body made of ice and rock, a typical cometary nucleus, should be utterly dormant. It should be a frozen, inert relic, its volatile materials locked solid in a deep freeze, indistinguishable from a common asteroid. It should be silent, but it is not. Against all logic, against our established understanding of cometary physics, 3I divided by Atlas is awake. It is active. It is, for lack of a better word, alive, with a strange, cold fire. It is exhaling a ghost of an atmosphere into the vacuum, and the primary component of this exhalation, the very substance it is venting into the void, is water. Not a mere trace, not a subtle hint, but a prodigious, unbelievable quantity of water. Every second, this small, dark object, no more than a few kilometers across, releases tens of kilograms of water vapor into space. It is bleeding a river into the emptiness. Imagine a cosmic iceberg, adrift in the coldest ocean imaginable, inexplicably steaming as if it was sitting on a volcanic vent. This is the fundamental, baffling contradiction of 3I divided by Atlas. It is a snowball melting in the deepest freezer in the solar system. This is its silent scream, an act of impossible transformation that defies its environment. It raises a cascade of questions that ripple through the foundations of astrophysics. What unknown engine is driving this process? What source of energy, hidden from our view, is warming this object from within, or causing its very substance to sublimate in defiance of the cold? Why is it behaving in a way we've never seen from one of our own comets at such a staggering distance? And perhaps the most profound question of all, this object is a messenger, a physical sample delivered to our doorstep from another star's family. So, what is this strange behavior, this impossible whisper of water, trying to tell us about the distant, unknown world from which it was born. Now, let us turn our gaze from the abstract to the specific. Let us focus our collective attention on that single, unassuming point of light, drifting patiently against the tapestry of the fixed stars. Its official designation is 3I, divided by Atlas, a name that is both clinical and, in its own way, poetic. The 3I identifies it as only the third interstellar object ever confirmed to have entered our solar system, a visitor from the vast, uncharted territory between the suns. The name Atlas comes from the terrestrial survey that first noticed its faint signature, the Asteroid Terrestrial Impact Last Alert System, an instrument designed to be our planetary sentry to watch for dangers approaching from the dark. Yet, this object was not a danger. It was a mystery. It is not a member of our familiar celestial family. The planets, asteroids, and comets of our solar system are all bound by the invisible tether of the sun's gravity. They are natives, born from the same swirling protoplanetary disk of gas and dust some 4.5 billion years ago. They follow predictable, elliptical paths, their journeys endlessly repeating in a cosmic dance choreographed by gravity. They are ours. But 3I divided by Atlas is different. Its trajectory is not a closed loop, but an open-ended hyperbola, a path that speaks of immense initial velocity, a speed that could not have been imparted by our sun alone. It is a cosmic slingshot, shot from the gravitational bow of another star, long ago and far away. It has traveled for an unknowable duration, perhaps millions of years, crossing the desolate void between stellar systems. It is an emigrant, a wanderer, a true alien in the most literal sense of the word, originating from another world, another Genesis. And as it navigates the outer reaches of our solar system, it is doing something that, by all rights, should be impossible. To understand this paradox, you must first picture its environment. It moves through a realm of profound cold, far beyond the orbit of Mars, beyond the asteroid belt, journeying through the frigid domain of the gas giants. At this immense distance, the sun, our brilliant, life-giving star, is but a shadow of its familiar self. It would appear not as a disk, but as an intensely bright star, its warmth and energy diluted by billions of kilometers of empty space. The sunlight reaching 3I divided by Atlas is a feeble caress, hundreds of times weaker than the light that bathes our own planet. In such conditions, a body made of ice and rock, a typical cometary nucleus, should be utterly dormant. It should be a frozen, inert relic, its volatile materials locked solid in a deep freeze, indistinguishable from a common asteroid. It should be silent, but it is not. Against all logic, against our established understanding of cometary physics, 3I divided by Atlas is awake. It is active. It is, for lack of a better word, alive with a strange cold fire. It is exhaling a ghost of an atmosphere into the vacuum, and the primary component of this exhalation, the very substance it is venting into the void, is water. Not a mere trace, not a subtle hint, but a prodigious, unbelievable quantity of water. Every second, this small, dark object, no more than a few kilometers across, releases tens of kilograms of water vapor into space. It is bleeding a river into the emptiness. Imagine a cosmic iceberg, adrift in the coldest ocean imaginable, inexplicably steaming as if it was sitting on a volcanic vent. This is the fundamental, baffling contradiction of 3I divided by Atlas. It is a snowball melting in the deepest freezer in the solar system. This is its silent scream, an act of impossible transformation that defies its environment. It raises a cascade of questions that ripple through the foundations of astrophysics. What unknown engine is driving this process? What source of energy, hidden from our view, is warming this object from within, or causing its very substance to sublimate in defiance of the cold? Why is it behaving in a way we've never seen from one of our own comets at such a staggering distance? And perhaps the most profound question of all, this object is a messenger, a physical sample delivered to our doorstep from another star's family. So, what is this strange behavior, this impossible whisper of water, trying to tell us about the distant, unknown world from which it was born? To comprehend the profound strangeness of our interstellar visitor, we must first step back. We must journey into the familiar, into our own celestial backyard, and paint a portrait of what we consider to be a normal comet. For in the world of science, the declaration of an anomaly is meaningless without a rigorously defined baseline of normalcy. The exception cannot be celebrated or even recognized without a deep understanding of the rule. So, let us speak of the rule. Let us explore the life and times of a common comet, one born of our own sun's nebula. We often hear them described with a charmingly simple phrase, dirty snowballs. And while this analogy is a useful starting point, it barely scratches the surface of their true nature. They are more than mere inert objects. They are cosmic fossils, pristine time capsules left over from the very dawn of our solar system. 4.5 billion years ago, when the sun was a newborn star and the planets were just beginning to coalesce from a vast spinning disk of gas and dust, not all of the material found a home. In the chaotic gravitational billiards of that era, vast quantities of icy debris were flung outwards, scattered to the far, frozen frontiers of the sun's influence. Here, in the unimaginable cold and dark, they have resided ever since, forming two great reservoirs of primordial matter. The first is the Kuiper Belt, a flattened disk of icy bodies that begins just beyond the orbit of Neptune, a sort of cosmic suburbia. The second, and far more vast, is the Oort cloud. It is not a disk, but a colossal, spherical shell of trillions of cometary nuclei that envelops our entire solar system, extending almost a light year into the space between ourselves and the nearest stars. This is the true homeland of the long-period comets. In this realm, they are kings in a kingdom of absolute stillness. For millions, even billions of years, a comet in the Oort cloud is in a state of near-perfect hibernation. It is a lump of rock and exotic ices, water ice, yes, but also frozen carbon dioxide, methane, ammonia, and carbon monoxide, all bound together with silicate dust and organic compounds. At this distance, the sun is just the brightest star in the sky, its warmth utterly negligible. The comet is quiescent, dormant, a dark and silent ghost drifting through an eternal night. But its story is not destined to end there. Occasionally, the subtle gravitational nudge of a passing star or the tidal forces of our galaxy itself will disturb one of these sleeping giants. This gentle push is enough to dislodge it from its ancient, stable orbit and send it on a long, slow fall inwards towards the heart of the solar system. This is the beginning of its great transformation, its awakening. As the comet crosses the orbit of Neptune, then Uranus, then Saturn, very little changes. It remains a frozen, inactive nucleus. But as it continues its inexorable plunge and passes the orbit of Jupiter, something magical begins to happen. The sun's radiation, though still weak, is now potent enough to begin working on the comet's surface. It doesn't melt the ice in the way we might imagine, for in the vacuum of space, liquid water is a fleeting impossibility. Instead, a far more elegant process occurs: sublimation. The ices on the comet's surface transition directly from a solid state into a gaseous one, bypassing the liquid phase entirely. Imagine a piece of dry ice on a warm countertop fizzing and smoking as it turns directly into carbon dioxide gas. Now imagine that on a planetary scale. This outgassing is the comet's first breath. As these volatile ices vaporize, they do not leave gently. They erupt from the surface in powerful jets, carrying with them vast quantities of dust and rock particles that have been trapped within the ice for billions of years. This mixture of liberated gas and dust expands outwards, forming a vast, tenuous, and temporary atmosphere around the nucleus. This ghostly shroud is called the coma, and it is this coma, reflecting the distant sunlight, that causes the comet to bloom in our night sky, transforming from an invisible piece of rock into a luminous celestial flower. The coma can swell to an immense size, often becoming larger than the planet Jupiter, all generated from a nucleus that may only be a few kilometers across. But the transformation is not yet complete. As the comet gets ever closer to the sun, two powerful solar forces begin to sculpt this expanding cloud of material, creating the feature most synonymous with a comet: its magnificent tails. The first force is the sunlight itself. Photons, though massless, carry momentum. The constant stream of light pushing against the tiny dust particles in the coma is enough to gently nudge them away from the sun, forming a broad, curved, and often yellowish tail. This is the dust tail. It shines by reflecting sunlight, and its gentle curve traces the comet's orbital path like the wake behind a ship. The second force is more violent. The sun constantly emits a supersonic stream of charged particles called the solar wind. This solar breath sweeps through the solar system at hundreds of kilometers per second. When it encounters the gases in the coma, it ionizes them, stripping electrons from their atoms, and then violently pushes them away. This creates the second tail, the ion tail. It is typically thinner, straighter, and often glows with a brilliant blue light. And because it is driven by the solar wind, this ion tail always, without exception, points directly away from the sun, regardless of which way the comet itself is traveling. At its closest approach to the sun, the comet is a truly spectacular sight, a dynamic battleground of cosmic forces. It is at its most brilliant, but also at its most self-destructive, shedding tons of its ancient material every second. Then, its gravitational dance swings it back around, and it begins its long journey outwards back towards the cold. As it retreats, the process reverses. The sun's influence wanes, the sublimation slows, the jets die down, the coma dissipates, and the tails fade into nothingness. The comet returns to its dormant state, a silent block of ice and rock, to await its next fiery rendezvous in perhaps thousands or millions of years. This is the fundamental rhythm of a comet's life, the established rule. It is a story entirely dependent on one single protagonist, the Sunday. It is the sun's heat that drives the sublimation, the sun's light that pushes the dust, and the sun's wind that shapes the ions. The entire magnificent display is a direct response to proximity to our star. Without that warmth, a comet is silent. And this is the very heart of the paradox. 3I divided by Atlas was performing this grand awakening, this act of sublimation and exhalation, while it was still deep within the frozen realm, where the sun's power should have been far too weak to stir it from its slumber. It was breaking the most fundamental rule of its kind. The portrait we have just painted, of the dirty snowball awakening in the sun's embrace, is the story of our family. It is an intimate local narrative. The comets of the Oort cloud, the asteroids of the main belt, the planets in their majestic orbits, every single celestial body that we have studied in detail throughout human history, shares a common ancestry. They were all born from the same spinning cloud of primordial gas and dust, the solar nebula. They are gravitationally bound to our sun, part of a single, vast, and intricate system. They are, in a very real sense, us. Their chemical composition is our chemical composition. Their history is our history. For millennia, our entire conception of the cosmos was necessarily limited to this single data point, this one isolated family. We could look out at the myriad stars in the night sky, and we could deduce their distance, their temperature, their mass. We could watch as they too hosted families of their own planets. But the chasm between seeing and touching was absolute. The stars are separated by distances so colossal they defy human intuition. To speak of light years is to use a convenient shorthand for a number so large it loses all meaning. The nearest star to our sun, Proxima Centauri, is over 40 trillion kilometers away. Our fastest spacecraft, the Parker Solar Probe, traveling at over 500,000 kilometers per hour, would still take more than 8,000 years to cover that distance. The stars, and the worlds that circle them, were destined to remain forever as points of light, subjects of remote observation, but never of direct physical inquiry. We could analyze the light that traveled from them, but we could never hope to hold a piece of them in our hands, to subject a fragment of their reality to our instruments. It was the ultimate cosmic quarantine. We were confined to our own home, able to look out the windows at the neighborhood, but never able to step outside and collect a sample from a neighbor's garden. Then, the universe decided to make a delivery. The letter I in the name 3I divided by Atlas is not merely a cataloging convention, it is a revolution. It stands for Interstellar, and it signifies a complete paradigm shift in our relationship with the galaxy. It announces that this object is not one of ours. It is not bound by the sun's gravity. It is a tourist, a drifter, a transient just passing through. Its path is not the gentle repeating ellipse of a planet or a resident comet, but a wide, open-ended hyperbola. This trajectory is its passport, the unambiguous proof of its foreign origin. It tells us that 3I divided by Atlas began its journey not in our Oort cloud, but in the gravitational embrace of another star. It was ejected from its home system, perhaps by the gravitational jostling of a large planet, and flung into the interstellar void. For an unimaginable span of time, it journeyed through the great dark, a solitary traveler in the lonely space between the suns, before its path, by pure chance, intersected with our own small sphere of influence. For a brief moment on a cosmic timescale, it is our guest. It will arc around our sun and then, its trajectory irrevocably altered but its freedom intact, it will depart, continuing its endless journey back into the deep. But during its short stay, it offers us a gift of incalculable value. It is a physical piece of another solar system delivered directly to our doorstep. It is a free sample return mission from a star we may never even be able to identify. Suddenly, the chasm between seeing and touching has been bridged. We do not need to send a probe on an impossible 1,000-year journey. The universe has sent the probe to us. This is why the discovery of every interstellar object is a monumental event in science. The first, 1I Oumuamua, detected in 2017, was a true enigma. It was a small, strangely elongated, rocky object that showed no cometary activity, yet it was accelerating away from the sun as if propelled by some unseen force. It was a profound puzzle that challenged our classifications and ignited intense debate. Was it a new type of natural object? A nitrogen iceberg chipped from a Pluto-like planet? Or something else entirely? It left us with more questions than answers. The second, 2I divided by Borisov, discovered in 2019, was, in comforting contrast, much more familiar. It looked and behaved almost exactly like one of our own long-period comets, displaying a distinct coma and tail. It was a profoundly important discovery because it suggested that the processes that formed comets in our solar system might be common throughout the galaxy. It was a hint of universality. And now, we have 3I divided by Atlas. It is the third such confirmed messenger, another precious data point in our quest to understand our place in the cosmos. Each one of these visitors is a unique ambassador from an unknown stellar nation. By studying its composition, we can analyze the chemistry of the nebula where it was born. Does it contain the same ratios of elements as our own system? Does it carry complex organic molecules, the fabled building blocks of life? Its isotopic ratios, the specific flavors of its atoms, are a direct fingerprint of its parent star. By observing its structure and behavior, we learn about the physical conditions in other protoplanetary disks. Were they hotter or colder than our own? More or less dense? Each interstellar object helps us answer the most fundamental of questions. Is our solar system typical? Is the way planets and life emerged here a common cosmic script? Or are we a rare and beautiful exception? 3I divided by Atlas is not just a rock. It is a vessel carrying ancient secrets. It is a page torn from the encyclopedia of another world, a message in a bottle that has washed ashore on our cosmic island after a journey across an ocean of unimaginable scale. And that is why its strange, anomalous behavior is so critically important. If one of our own comets behaves unexpectedly, we might attribute it to a local quirk. But when a messenger from another star system behaves in a way we cannot explain, it carries a far deeper implication. We are not just witnessing a cometary anomaly. We are potentially witnessing a galactic norm that is alien to our own experience. It forces us to confront the humbling possibility that our well-established rules, the familiar story of the dirty snowball, may just be the local bylaws, not the universal constitution. With the stage now set, and our messenger from the stars in place, we must become detectives. Every great mystery begins with a meticulous examination of the scene, and our scene is a patch of cold, empty space, billions of kilometers from Earth. Our chief investigator in this cosmic drama is the James Webb Space Telescope, arguably the most powerful instrument of perception humanity has ever created. Launched on Christmas Day 2021, the JWST is not an ordinary telescope. It is a masterpiece of engineering designed to see the universe in a light that is invisible to our eyes, the infrared spectrum. It is a time machine and a ghost hunter, capable of seeing the faint, ancient light from the first galaxies and peering through clouds of cosmic dust to witness the birth of new stars. Its giant, golden, honeycombed mirror is shielded from the sun's warmth by a 5-layer sunshield the size of a tennis court, allowing it to cool down to the extreme temperatures necessary to detect the faintest heat signatures from the distant universe. It is the perfect tool for our investigation, an eye specifically designed to see the warm breath of a comet in the coldest of places. And so, this powerful eye was turned towards our interstellar visitor. When the JWST fixed its gaze upon 3I divided by Atlas, the comet was navigating the desolate expanse of the outer solar system. To give you a sense of place, it was moving through a region far beyond the orbit of Saturn. From its vantage point, the Sun would appear more than 10 times smaller in the sky than it does to us, its power diminished by a factor of over 100. The radiant energy that bathes our world, that drives our weather and fuels our biosphere, is, out there, a mere whisper. It is an environment of perpetual twilight. This extreme distance dictates an equally extreme temperature. The surface of 3I divided by Atlas, the very crust from which this activity was emanating, was calculated to be hovering at around 200 degrees Celsius below zero. This is a cold that defies our terrestrial experience. It is a temperature far colder than the bleakest winter night in Antarctica. It is a cold so intense that the nitrogen and oxygen that make up the air we breathe would instantly freeze into a solid state. In this environment, water ice undergoes a fundamental change in character. It is no longer the slippery, fragile substance we know. It becomes a mineral. It achieves a structural integrity and hardness comparable to granite. For this ice to sublimate, for its molecules to break their powerful crystalline bonds and escape into the vacuum, requires a significant input of energy. According to our well-established models of thermodynamics, the faint, diluted sunlight reaching 2I divided by Atlas simply does not provide it. The energy budget does not balance. The numbers do not add up. The comet should have been a silent, frozen rock. It should have been as inert as the moons of Pluto. All of our science, all of our observations of the hundreds of comets born in our own solar system, told us that the grand show of outgassing, the creation of a coma, was a spectacle reserved for the inner solar system, for the regions inside the orbit of Jupiter, where the sun's furnace truly begins to blaze. And yet, the impossible was happening. The scene was set for an event that should not be occurring. A rock-solid block of ice was fizzing in a domain of absolute frost. The stage was empty, the theater was dark, and yet a ghost was singing, and James Webb was there to record the song. Our human experience of the universe is a story told in a very narrow dialect of light. We are creatures of the visible spectrum, our eyes tuned to a sliver of the electromagnetic rainbow that our sun happens to produce most abundantly. We see the world in reflected glory. The blue of the sky is scattered sunlight, the green of a leaf is the light it has rejected. Our perception is based on surfaces, on the light that bounces off the outer shells of things. It is a beautiful but profoundly limited mode of seeing. We are, in essence, watching the cosmic stage illuminated by a single brilliant spotlight, able to see only the actors it happens to strike. But to truly understand the universe, we must learn to see in the dark. We must learn to see not just the brilliant reflections, but the subtle, intrinsic glows and the even more subtle shadows that exist outside our biological range. This is the realm of the James Webb Space Telescope. It is an eye built not for the bright spotlight, but for the faint, ambient warmth of the stage itself. Its vision is not in the visible, but in the infrared. Infrared light is, in its most basic sense, the light of heat. Every object in the universe with a temperature above absolute zero, from the mightiest star to the smallest grain of dust, emits a faint glow of infrared radiation. JWST, chilled to an incredible 50 degrees above absolute zero, is sensitive enough to see this universal heat signature. But its genius, and the key to this entire discovery, lies not just in its ability to see this faint light, but in its power to dissect it. For light is far more than just a source of illumination. It is the universe's primary carrier of information. It is a messenger, and written within its very structure are the secrets of the things it has encountered on its journey. The technique used to read this message is called spectroscopy, and it is one of the most powerful tools in the arsenal of science. At its heart is a simple, beautiful principle. When you pass a beam of white light through a prism, it splits into the familiar rainbow of colors, a continuous spectrum. This is the light in its pure, unfiltered state. But if, before reaching the prism, that beam of light passes through a cloud of gas, something extraordinary happens. When the light emerges on the other side and is split by the prism, the rainbow is no longer perfect. It is scarred. It is interrupted by a series of thin, black lines. These are absorption lines. They are the fingerprints of the atoms and molecules that were in that cloud of gas. Each type of molecule, be it oxygen, methane, or in our case water, has a unique quantum structure. Because of this structure, it can only absorb energy at very specific, discrete frequencies or colors of light. It is as if each molecule has its own unique musical chord it is capable of hearing. When the full symphony of white light passes through, the molecule listens for its chord and plucks those specific notes out of the music, absorbing their energy. The rest of the symphony passes through untouched. What JWST did was not to look at 3I divided by Atlas itself. Looking at the faint, reflected light from its dark, icy nucleus would tell us very little. Instead, it performed a far more elegant and subtle observation. It waited. With unimaginable precision, it oriented itself and waited for the comet in its slow, silent journey to pass in front of a distant, unrelated star. This star, perhaps hundreds of light years away, acted as a perfect, pristine backlight. Its light, a continuous spectrum, began a long journey towards us, a pure message traveling through the void. For the final few thousand kilometers of that immense journey, this ancient starlight passed through the most tenuous, most invisible part of the comet, its coma. This vast, ghostly halo of gas, sublimated from the comet's surface, is so incredibly diffuse that it is practically a vacuum by terrestrial standards, and yet it is not empty. It is populated by the molecules of water, carbon dioxide, and other volatiles released from the nucleus. In the fleeting moment that the starlight traversed this cloud, the molecular drama unfolded. The water molecules, adrift in the cold dark, encountered the stream of photons. Vibrating and rotating, they did what physics dictates they must do. They absorbed the light corresponding to their specific resonant frequencies. They plucked their unique chord of infrared notes from the starlight. The light then continued on its way to the golden mirror of JWST, but it was no longer the same. It was now an imprinted message. It was a letter that had been opened, read, and sealed again with a new signature. When this altered light reached the telescope's instruments, the spectrographs performed their prismatic magic. They spread the incoming infrared light into its constituent colors, creating a spectrum, and there, etched into the light of that distant anonymous star, was a barcode. It was a pattern of dark absorption lines so clear, so precise, so unambiguous, that it could only mean one thing. It was the unmistakable fundamental signature of water, H2O. It was not a picture of ice. It was not a photograph of a geyser. It was something far more profound. The direct, physical proof of the presence of water vapor, written in the language of light itself. The universe was not shouting, it was whispering, and the James Webb Space Telescope was built to listen. To detect the mere presence of water in the cosmos is, in itself, a remarkable feat. But science, in its relentless pursuit of understanding, is not content with simple discovery. It seeks to measure, it seeks to quantify. The spectral barcode that the James Webb Space Telescope recorded was not just a binary signal of yes or no. The darkness of those absorption lines, their depth and breadth, contained a second layer of information. It spoke not just of what was there, but of how much. The deeper and broader the line, the more water molecules were present in the path of the starlight, each one contributing to the absorption, each one adding its voice to the chorus. And when the astrophysicists, with painstaking care, calibrated their instruments and ran the calculations, when they translated that silent barcode of light into the language of mass and volume, they arrived at a figure that was, to put it mildly, astonishing. The number they calculated was approximately 40 kilograms. 40 kilograms of water being vented into the vacuum of space every single second. This is not a number to be read and dismissed. It demands contemplation. It requires us to build a scale for it in our minds. 40 kilograms a second. What does that truly mean? Imagine standing in a quiet room and, every second, watching as two large, heavy office water cooler jugs, the 20-liter kind, simply vanish into thin air. 1 second, they are there. The next, gone, transformed into an invisible vapor. Tick, 2 jugs. Tock, 2 more. Every beat of your heart, another 80 pounds of water cast out into the void. It is the flow rate of a municipal fire hydrant, open to full blast, a torrent of life-giving fluid. In a single minute, 3I divided by Atlas expels nearly 2.5 metric tons of its own substance into space, the weight of a large car. In an hour, that becomes 144 tons. In a single day, it loses over 3,400 tons of its mass, all of it in the form of water, the most precious of cosmic commodities. And it performs this prodigious, unrelenting act of self-exhalation in the absolute worst place imaginable for such a thing to occur. It is generating this river of vapor in an environment so cold that the very concept of liquid water is a physical absurdity. It is not being boiled by a furnace, it is sublimating in a cryogenic freezer. This is the crux of the matter, the very heart of the scientific bewilderment. We have seen our own comets perform such feats, and far greater ones, but only when they are grazing the orbit of Earth, or even Mercury, when they are being relentlessly blasted by the full, terrifying power of the Sunday. For a comet to produce such an output beyond the orbit of Saturn is without precedent. It is a violation of the known rules. It is like discovering a waterfall in the middle of a desert, with no river to feed it and no mountain to source it. The number, 40 kilograms per second, is more than just a measurement. It is a declaration. It is a direct statement from the object itself, a testament to the power of the hidden engine that is driving it. It tells us that this is no mere surface-level fizzing, no gentle, passive outgassing. This is a powerful, dynamic, and sustained process. It is a cosmic heartbeat, a steady, rhythmic pulse of matter into the emptiness, broadcast from a place of deep, primordial cold. This figure transforms the mystery from a qualitative curiosity into a quantitative, physical problem. The question is no longer simply, why is it active? The question, now armed with the stark reality of this number, becomes far more urgent, far more specific. What conceivable mechanism, what hidden source of energy could possibly have the power to liberate 40 kilograms of rock-hard, super-chilled ice every single second in the dark and frozen wastes of the outer solar system? Faced with a paradox that seems to defy the known laws of physics, the scientific mind does not immediately leap to conclusions of alien technology or undiscovered forces. It practices a form of intellectual discipline, a principle of elegant simplicity often referred to as Occam's razor. The principle states that among competing hypotheses, the one with the fewest assumptions should be selected. In essence, before we invent a new and exotic explanation, we must first exhaust all the possibilities that lie within our existing framework of knowledge. We must ask, is there a known mechanism, a familiar process, that could be acting in an unfamiliar way to produce this extraordinary result? This leads us to our first and most rational hypothesis. Perhaps the answer to the riddle of 3I divided by Atlas does not lie in the water at all. Perhaps the water is not the engine of this process, but merely a passenger. The mistake might be in assuming that water ice is the primary fuel source, when in fact it is merely the exhaust, the visible evidence of a far more volatile reaction happening just beneath the surface. We must remember what a comet truly is. Not a pure snowball, but a dirty one. A composite. A heterogeneous mixture of materials forged in the primordial nebula. While water ice is its most abundant component, it is far from the only one. Frozen within its matrix, like pockets of air in a block of ice, are other, far more sensitive substances. These are the supervolatiles, frozen gases like carbon dioxide, CO2, and carbon monoxide, CO2. In our daily lives, we know carbon dioxide as the invisible gas we exhale, the fizz in a carbonated drink. To turn it into a solid, into what we call dry ice, you must cool it to nearly 80 degrees below 0 Celsius. Carbon monoxide, a molecule forged in the hearts of dying stars, requires even more extreme cold, solidifying at over 200 degrees below 0. In the frigid nursery of the Oort cloud, or the interstellar medium where 3I divided by Atlas was born, these temperatures are the norm. So, these gases are locked in their solid, icy state, intermingled with the far more stable water ice and silicate dust. Herein lies the key. The faint, anemic sunlight in the outer solar system may be utterly insufficient to sublimate the granite-hard water ice, but for these supervolatiles it is more than enough. That gentle, distant warmth is, for them, a scorching heat wave. It is a match held to a block of solid gasoline. This hypothesis, therefore, posits that the energy from the sun, weak as it is, penetrates the dark, porous surface of the comet and reaches a buried pocket of solid carbon dioxide or monoxide. As this pocket warms, it begins to sublimate rapidly, transforming directly into a high-pressure gas trapped beneath a crust of stubborn water ice and dust. The pressure builds, a silent, gathering force in the heart of the frozen nucleus. What happens next is not a gentle fizzing, but a violent, explosive release. The pressure overwhelms the tensile strength of the overlying crust, and a jet erupts into space. The most powerful analogy is not that of a melting ice cube, but of a champagne bottle that has been violently shaken and then uncorked. The escaping carbon dioxide gas doesn't just flow out, it explodes. And this is the critical part of the hypothesis. This violent, high-velocity jet of CO2 gas acts as a powerful propellant. It does not leave alone. It carries with it the surrounding material. The water ice, still frozen solid, is not sublimating on its own. It is being physically ripped from the nucleus and carried along for the ride. It is shrapnel in a gaseous explosion. The 40 kilograms per second that James Webb observed is not 40 kilograms of sublimated water vapor, but a mixture of CO2 gas, carrying with it a payload of fine water ice crystals and dust. The water is an inert bystander, thrown into space by the fury of its more volatile neighbor. This explanation is elegant. It is powerful. It does not require us to invent new physics. It uses the known, expected ingredients of a comet to create the observed effect. It neatly solves the energy paradox by shifting the thermodynamic burden from the stable water to the highly unstable supervolatiles. It is a testament to the idea that sometimes the most profound mysteries are not solved by finding a new rule, but by better understanding the consequences of the rules we already know. The hidden fuel hypothesis is clean, logical, and relies on familiar chemistry. It is an excellent candidate for the truth. But what if the anomaly we are witnessing is not a matter of composition, but of construction? What if the secret of 3I divided by Atlas lies not in the exotic ingredients mixed within its ice, but in the very architecture of the ice itself? This brings us to a second, more esoteric possibility, one that delves into the quantum mechanics of the frozen state. It proposes that the comet is not being powered by a chemical reaction, but by a physical transformation, an internal release of energy that has been stored within its very structure for millions, perhaps billions, of years. To understand this, we must first abandon our terrestrial intuition about ice. The ice cubes in your drink, the snowflakes on a winter's day, the glaciers that carve mountains, all of this is crystalline ice. It is a substance of profound order. On a molecular level, its H2O molecules are not just a jumbled pile. They are arranged in a precise, repeating, hexagonal lattice. Each molecule is locked into a specific orientation relative to its neighbors, forming a strong and stable structure. Think of it as a perfectly built wall, with every brick aligned just so. This formation, the crystal lattice, represents the lowest possible energy state for water molecules when they freeze. It is the most stable, most comfortable arrangement they can adopt. And because it is the lowest energy state, it takes a significant amount of energy to break those bonds, to liberate a molecule from the crystal and turn it into a gas. This is why the granite-hard ice of a normal comet is so difficult to sublimate in the outer solar system. But there is another kind of ice. It is an ice that almost never forms on Earth, an alien substance born only in the extreme and bizarre conditions of the interstellar medium. It is called amorphous ice. The word amorphous means without shape, and that is precisely what it is. In the near absolute zero temperatures and near perfect vacuum between the stars, when stray water molecules happen to bump into a cold grain of dust, they do not have the time or the thermal energy to shuffle around and find their proper, ordered place in a crystal lattice. They simply stick where they land. The result is not a neatly ordered wall, but a chaotic, jumbled heap. The molecules are frozen in a state of complete disarray, a snapshot of liquid chaos solidified in an instant. This disordered structure is inherently unstable. It is a high-energy state. The system is pregnant with potential energy. It wants to rearrange itself into the more stable, lower-energy crystalline form, but it is trapped, frozen in place by the extreme cold. Now, let us apply this concept to our interstellar messenger. 3I divided by Atlas was not born in the relatively mild conditions of our own solar system's protoplanetary disk. It was likely formed in the much colder, much more tenuous environment of a dense molecular cloud in interstellar space. It is therefore highly probable that it is not a block of familiar crystalline ice, but a colossal repository of this high-energy, amorphous ice. For eons, as it drifted through the void, it remained in this frozen, chaotic state, a sleeping giant of stored energy. Then, it entered our solar system. As it journeyed inwards, the temperature, while still incredibly cold, began to rise ever so slightly. The faint caress of distant sunlight provided a tiny, almost imperceptible nudge of thermal energy. For crystalline ice, this nudge would mean nothing. But for the unstable, amorphous ice, it was everything. It was the catalyst. It was just enough activation energy to allow a few of the jumbled molecules to break their bonds, shift, and snap into their proper, ordered, crystalline positions. And this is where the magic happens. A system moving from a high-energy, disordered state to a low-energy, ordered state must, by the fundamental laws of thermodynamics, release the difference in energy. This process of crystallization is exothermic. It generates its own heat. A tiny patch of amorphous ice snaps into its crystalline form, and in doing so, releases a small puff of warmth. This warmth then provides the activation energy for the neighboring patch of amorphous ice to do the same, which in turn releases its own heat, triggering the patch next to it. A chain reaction begins. A slow, creeping wave of transformation, a crystallization front, begins to move through the comet's nucleus. It is a process of the comet consuming its own internal chaos to generate warmth. This internally generated heat, born from the very fabric of the ice reordering itself, is the hidden engine. It is this warmth, not the faint sunlight, that then provides the potent energy required to sublimate the newly formed and now much more volatile crystalline ice on the surface, driving the immense 40 kg per second outflow we observe. The sun is not the furnace. It is merely the spark that ignites a long, slow-burning fire that was laid down millions of years ago in the heart of a stellar nursery. This hypothesis is beautiful in its complexity. It suggests 3I divided by Atlas is not just a passive object being acted upon by the sun, but an active, dynamic system undergoing a profound internal metamorphosis, powered by the release of its own primordial history. We have explored the elegant logic of hidden fuels and the profound physics of amorphous ice. Both hypotheses are robust, scientifically grounded attempts to explain the anomaly of 3I divided by Atlas within the boundaries of what we know. They are attempts to fit this strange, new puzzle piece into the grand picture of the cosmos that we have so carefully assembled. But we must, with both humility and intellectual courage, confront a third possibility. What if the puzzle piece doesn't fit, not because we are looking at it incorrectly, but because it belongs to an entirely different puzzle? This brings us to our most audacious, and perhaps most important, hypothesis. It is the simple yet paradigm-shattering idea that the strange behavior of 3I divided by Atlas is not strange at all. Perhaps for the place where it was born, its behavior is perfectly ordinary. The anomaly then lies not with the object, but with our expectations. Our entire science of comets, our beautifully detailed models of sublimation and outgassing, are all built upon a single, potentially biased sample set, the comets of our own solar system. We have studied hundreds, even thousands of them. We have landed probes on them, analyzed their dust, and categorized their behaviors. But they all share a single common heritage. They were all born from the same cloud of gas, under the influence of the same star, and subjected to the same evolutionary history. We have been studying one forest, assuming its trees are representative of every forest in the world. 3I divided by Atlas arrives as a seed from a distant alien jungle, and it is growing into a tree we do not recognize. What does this truly mean? It means we must question our most basic assumptions. We assume that the chemical recipe for comets is universal. But is it? Could it be that the protoplanetary disk where 3I divided by Atlas formed was richer in certain elements, or contained exotic molecular compounds that are rare or non-existent in our own system? Perhaps there is some unknown, hypervolatile substance mixed within its ice, something that makes even carbon monoxide look stable, which is driving this activity. A substance we have not yet conceived of because it was never a significant ingredient in our own corner of the galaxy. Furthermore, we assume the physical conditions of formation are broadly similar everywhere. But what if 3I divided by Atlas was born in a much colder, denser region of its parent, nebula, than is typical for our comets? Such conditions could lead to a physical structure, an internal porosity and thermal conductivity that is radically different from anything we have encountered. Perhaps its surface is like a cosmic sponge, able to absorb and concentrate the faint solar heat with astonishing efficiency. Or maybe its interior is a labyrinth of interconnected vents, allowing deeply buried volatiles to escape with an ease that the consolidated nuclei of our comets do not permit. This line of reasoning forces us into a state of profound epistemological humility. It reminds us that our science is a product of our location. We stand on a small planet, circling an average star, in a quiet suburb of a vast galactic city. To assume that the local customs we observe here apply to the entire metropolis is a form of scientific provincialism. 3I divided by Atlas is an ambassador from another district, and it is speaking a dialect we do not understand. Its impossible plume of water is not just a physical phenomenon, it is a message. It is a caution against the arrogance of universality. It is a tangible piece of evidence suggesting that the galaxy may be far more diverse, far more varied in its creations than we have ever allowed ourselves to imagine. It forces us to entertain the thrilling possibility that there isn't just one way to build a solar system, but countless ways. And if the comets are different, what does that imply about the planets? About the moons? About the potential for life? The strange behavior of 3I divided by Atlas, therefore, might be its most important feature. It is a direct challenge to our models. It is a gift, forcing us to expand our theories, to consider new variables, and to dream of chemistries and physics that lie beyond our immediate experience. It is the universe, in its infinite generosity, reminding us that our knowledge is not a destination, but a journey, and the map is still largely unwritten. In the end, we are left suspended in a state of profound and beautiful uncertainty. We have climbed the ladder of hypothesis, from the familiar comfort of known chemistry to the dizzying heights of speculative physics. And still, the summit remains shrouded in mist. We may never know with absolute certainty which explanation is correct. Our visitor is transient. It will not stay for a prolonged interrogation. It will round the sun, offer us a final fleeting glimpse, and then depart on its eternal journey back into the void, taking the ultimate truth of its nature with it. And perhaps this is the most important lesson it has to offer. In our modern age, we have become accustomed to answers. We carry devices in our pockets that can resolve nearly any factual question in an instant. We have mapped the human genome, split the atom, and peered back to the dawn of time. There is a subtle, creeping arrogance that can accompany such knowledge, a belief that the universe is, at its core, a solvable puzzle, a machine whose gears and levers will eventually yield all their secrets to our persistent intellect. And then, a small frozen rock drifts into our neighborhood from the great silent dark, and with a single, impossible act, it gently dismantles that certainty. 3I divided by Atlas is a cosmic rebuttal to our hubris. It is a 4.5 billion-year-old lesson in intellectual humility, delivered to our doorstep. Its strange fire does more than just challenge our astrophysical models. It holds up a mirror to the very nature of our knowledge. It reminds us that what we call scientific law is not an inscribed set of absolute truths handed down from on high. It is a human construct, a map drawn from the territory we have explored thus far. We have meticulously charted our own island, and even the surrounding archipelago of our solar system, and we have mistaken that for the entire world. 3I divided by Atlas arrives as a ship from a continent we never knew existed, with a hull made of a wood we cannot identify, and sails of a fabric we cannot weave. And it forces us to confront the humbling reality of the vast, uncharted ocean that remains. This is not a failure of science. On the contrary, it is science at its most pure and most vital. The goal of true inquiry is not to prove what we already know, but to gracefully, gratefully encounter the limits of our understanding. It is in these moments of beautiful confusion, when our maps are proven inadequate, that the real exploration begins. The existence of this object, regardless of the final explanation, compels us to face a fundamental truth. The universe is not obligated to conform to our expectations. It is not required to be simple or intuitive, or to operate according to the rules we have derived from our limited, local experience. Its capacity for novelty, for strangeness, for sheer, unadulterated wonder is likely infinite. 3 I divided by Atlas is a physical embodiment of that wonder. It is a whisper from the grander cosmos, a gentle but firm reminder that for all we have learned, we have only just begun to listen. The plume of vapor that streams from 3I divided by Atlas is not just a physical substance. To see it as merely 40 kilograms of H2O per second is to see a library as a mere collection of paper and ink. It is so much more. This vapor is a story. It is a narrative, written in the universal language of chemistry and physics, that has been traveling for millions of years, waiting for a reader. It is, in the most profound sense, a message in a bottle, cast into the great, dark ocean that separates the islands of the stars. The comet itself is the bottle, a vessel of ice and rock, weathered by an impossibly long journey, and the message contained within is the water itself. It is a liquid letter, and its every property is a word, a sentence, a chapter of an epic we can only begin to decipher. Its isotopic ratios, the specific flavors of its hydrogen and oxygen atoms, are a direct fingerprint of the stellar nebula where it was born, a signature of its parent sunday. The trace minerals and organic compounds caught within its vapor speak of the unique chemical environment of its home, a solar system that is likely now thousands of light years away, a system we may never see. It tells a tale of its genesis, a story of the conditions that prevailed in a corner of the galaxy we will never visit. But the message is not just about its past. It is also about our future and our place in the cosmic whole. It speaks a truth that resonates with the deepest questions our species has ever asked. It tells us, with the irrefutable evidence of its own existence, that water, the solvent of life, the molecule that courses through our own veins and constitutes the majority of our being, is not a provincial miracle. It is not a treasure exclusive to our own small world. It is a universal commodity. It exists out there, in the crushing cold and the profound emptiness between the suns. It is a fundamental part of the cosmic fabric, as common as the dust and the gas from which stars are born. This simple, elegant molecule, 2 parts hydrogen and 1 part oxygen, is adrift in the great dark, a vast and widespread potential, waiting for gravity to gather it into a protoplanetary disk, waiting to be incorporated into a newborn planet, waiting for the warmth of a new sun to thaw it into a primordial ocean, waiting to become the cradle for a new genesis. The water of 3I divided by Atlas is therefore a profound symbol of connection. It connects the chemistry of our own bodies to the chemistry of a star system we will never know. It is a thread of continuity that stretches across the seemingly unbridgeable void, a testament to the fact that the raw ingredients for life, as we understand it, are not a fluke, but a feature of the universe. In its silent, impossible plume, 3I divided by Atlas whispers the most hopeful of messages. We may be isolated, but the materials from which we are made are not alone. The grand, cosmic journey of discovery, the one that began with a single, anomalous point of light, ultimately brings us back to ourselves. It leads us back to the quiet human act of looking up at the night sky and wondering. The quest to understand the universe is perhaps not an outward journey at all, but an inward one. In seeking to decipher the secrets of an object like 3I divided by Atlas, we are, in reality, seeking to understand the boundaries of our own knowledge, the nature of our own perception. We ask, why is it doing that? But the deeper, unasked question is, what does it mean that we are here to witness it? The arc of this small, frozen wanderer will soon carry it beyond the reach of even our most powerful instruments. It will swing past our sun, a silent and fleeting guest, and then recede, its impossible plume fading as it returns to the interstellar dark from whence it came. Its passage through our lives is temporary. We may never fully resolve the beautiful paradox it has presented to us. We will be left with our theories, our data, and a lingering sense of awe. But to think of this as an ending is to miss the point entirely. The destination of science is not a final, immutable answer. The destination is the journey itself, the act of questioning, of observing, of being humbled, and of expanding our capacity for wonder. 3i divided by Atlas, in its brief and enigmatic visit, has done exactly that. It has broadened our sense of the possible. It has enriched our cosmic imagination, and then it will continue on its own path, an endless pilgrimage through the quiet cathedral of the galaxy, a silent testament to the mysteries that lie beyond our small sphere of light and warmth. And we will remain here, on the shore of our cosmic ocean, forever changed by the encounter. We may never know the complete truth of this particular messenger, but the act of observing it, of listening with our instruments and our intellect to its strange, cold song, has already given us the most profound gift. It has taught us that in the grand, majestic silence of the universe, the most meaningful form of understanding is not to have all the answers, but simply to have learned how to listen.